Hello guys, you are welcome to today's biology class, and in this class we are talking about the heart. Okay, so in our last class we have looked at the importance of the blood as a circulatory fluid and the types of blood that we have, but here now we are talking about the heart as a pumping organ. Okay, so the heart basically is a muscular organ that pumps blood throughout the body. For all the cells of the body, oxygen and nutrients, the heart is very important in pumping of blood. And this is the structure of the heart, as you can see, the various components which we are going to talk about very shortly. Let's start by looking at the chambers of the heart. The mammalian heart is divided into 4 chambers. You have the right auricle, you have the left auricle, the right ventricle, and the right and the left ventricle, and they are represented in the diagram that you are seeing on the screen. Here you have the left, and here you have the right. The left atrium, the right atrium, they are the upper chamber. The right ventricle, and the left ventricle, they are the lower chamber. Okay, so the auricles now, the right and the left auricles, they are the smaller chambers of the heart, and they also have thinner and less muscular wall. The reason why the walls of the auricles are thinner and less muscular is because they receive blood from the veins. Okay, and the blood coming from the vein, they are not at high pressure. So for the right auricle will receive deoxygenated blood from the vein and send those blood to the right ventricle. Okay, so when the blood gets to the right ventricle, the blood will then from there move into the lung to be oxygenated. Then the left auricle, on the other hand, will also will receive oxygenated blood. After the blood has been oxygenated in the lung, it comes back through the left auricle into the heart, and then the left auricle will blood now into the left ventricle, from where it will be circulated throughout the body. Now for the ventricles, they are larger chambers with stronger and thicker walls, and the reason is because it's responsible for pumping blood to the organs at high pressure. So because of the high pressure, the walls of the ventricles are thicker and they are also stronger. So for the right ventricle pumps blood through the pulmonary artery to the lungs, and that is the purpose of that is to oxygenate the blood. And when the blood has been oxygenated, it will back into the heart through the left atrium. Okay, and then the left ventricle, after the blood has been received by the left atrium, the left ventricle will then pump the blood throughout the body. So that is basically the function of those 4 chambers. They are very important, and that's their function. But these chambers also have what we refer to as valves. So we have 4 major valves in the mammalian heart. The first one is a tricuspid valve. The second one is a pulmonary valve. You also have the bicuspid, which you can also refer to as a mitral valve, and then the aortic valve. Okay, so here you have the diagram of those valves. You can see the pulmonary valve, you can see the pulmonary valve here, the tricuspid valve here, and then the mitral valve. Okay, you can see the mitral valve here, and then you can see the aortic valve, the last one here. Okay, so we now look at them one after the other. The tricuspid valve is also referred to as atrioventricular valve. When you say atrioventricular, it means it will only allow movement of blood from atrium to ventricle. That's why you call it atrioventricular valve. Okay, so the tricuspid valve is a valve that ensures that blood in the right ventricle goes into the pulmonary artery and reaches the lungs for oxygenation instead of being pushed back into the right atrium. So that means without tricuspid valve, it is possible for the blood to be pushed back. That means the blood will not be able to make its way into the artery and then into the lungs for oxygenation. That's the importance of the tricuspid valve. Okay, you also have the pulmonary valve. The pulmonary valve is what is also referred to as the luminal valve. The luminal valves are found in arteries that are leaving the heart, and their role majorly is to prevent blood from flowing backward from the arteries. The blood must continue to move in direction. So for the pulmonary valve, it lies in the pulmonary artery and the left ventricle, and that's where it will ensure that blood that is pumped into the pulmonary artery continues into the lung for oxygenation instead of returning into the heart. That's for the function of the pulmonary valve. How about the mitral valve? Like I said earlier, the mitral valve is also referred to as bicuspid valve, and it is also atrioventricular. That means it only allows movement of blood from the atrium into the ventricle. So this lies between the left atrium and the left ventricle, and it prevents blood from flowing back from the ventricle into the atrium, so that blood will continue to move from so that ensure that blood is pumped into the rest of the body instead of the blood moving back into the heart. So the bicuspid or the mitral valve will ensure that the blood moves into the ventricle, and then from the ventricle it goes directly into the aorta, which of course will send the blood to other arteries. Okay, and then the last one is the aortic valve. The aortic valve, as you might have guessed, the aortic valve needs a semi-lunar valve, just like the pulmonary valve also does. So the aortic valve prevents blood from flowing backward too, so that the blood will go directly from the aorta into the rest part of the body, instead of it moving back from the aorta back into the left ventricle. So that's for the valve. The valve basically helps to prevent backflow of blood, so that the blood will continue to move in a forward direction. Then we also have other parts of the heart like this, the superior and the inferior vena cava. Those are veins that send blood to the right atrium. The superior vena cava receives deoxygenated blood from the upper body and send it to the right atrium, while the inferior vena cava receives deoxygenated blood from lower part of the body and also send it to the right atrium. You also have the intraventricular septum. This is a wall that divides the heart into two, and it is very important so that the oxygenated blood and deoxygenated blood will not mix. So the interventricular septum serves as a barrier. You can see the ventricular septum here, okay, serves as a barrier that will not allow the deoxygenated blood in the right ventricle to mix with oxygenated blood in the left ventricle. So let's talk about the pulmonary artery and pulmonary vein. You know that artery normally carry oxygenated blood, like we have said, except pulmonary artery, while vein carry deoxygenated blood except pulmonary vein. So in this pulmonary artery now, it carries deoxygenated blood from the right ventricle to the lungs for oxygenation, while the pulmonary vein will take the oxygenated blood right from the lung back to the heart, so it can be pumped to other parts of the body. Okay, you can see here you have the pulmonary artery, and then you also have another pulmonary artery here. Okay, you have the pulmonary vein here. Okay, so those are the functions of pulmonary arteries and vein. Let's talk about the aorta now. The aorta is the largest blood vessel in the body, and basically is a central artery from which all the other arteries fill. That means the aorta is the one that supply all the other arteries that move blood around the body. It is very thick. It is very thick and extend all the way from our heart down to the pelvis. It's at the pelvis. It then split into two to become the femoral artery of each of the leg. Okay, so now we've talked about most of the other parts of the various component of the heart. Let's now talk about heartbeat. The heartbeat is caused by alternate contraction and relaxation of the four muscular chambers of the heart, and the heart beats about 70 to 75 times per minute, depending on whether the adult involved has just undergone a strenuous exercise or not. Okay, so and you can feel the impulse of your heartbeat. You can feel that in your hand by feeling. Then for the heart to beat, it consists of two phases. You have the diastole and then the systole. Talking about the diastole and the systole, you can see from the picture you have here, one is in relaxation mode and the other one is in contraction mode. The diastole is in relaxation mode while the systole is in a contraction mode. Okay, so what do you mean by diastole and systole? So diastole is the first stage of the heartbeat, during which the ventricle relax and expand as blood flow into them from the auricles and the vein. You can see this is the diastole. This you can see blood floating. The blood flowing now into the ventricle and thereby making it to relax, and of course that is infilling of the blood. Then on the other part you also have the systole. The systole is the second stage of the heartbeat, in which ventricles contract and force blood along the aorta. Look at it now. The heart that was relaxed in the diastole is now contracting the systole, and therefore you can see that the blood is then forced out of the ventricle now into the aorta, so that the blood will be pumped into other parts of the body. Okay, so thank you very much for watching. Okay guys, quickly I want to summarize what I've said so far using this diagram here. Look at it now. You have here the superior vena cava and you have the inferior vena cava. This the vena cava here, they are referring to the veins, the veins that bring blood from the other part, every other part of the body. So the superior vena cava that you have up here will bring blood from the upper part of the body, while the inferior vena cava will bring blood from the lower part of the body, and then they will take the blood into the heart through the atrium. You can see the arrow, and when the blood enters into the right atrium, it will then move from the right atrium through the tricuspid valve into the right ventricle. Hope you can see that. So when the blood gets into the right ventricle, the tricuspid valve, which we have here, will prevent the backflow of blood into the right atrium, so that the blood will keep going forward, and then the blood will move from the right ventricle. Remember that this blood that we have here is poor in oxygen. That means the blood is deoxygenated, so the blood needs to receive oxygen. The blood will then move from the right ventricle into the pulmonary artery. From pulmonary artery is going into the lungs to be oxygenated. But then you can see that the blood also passes through the pulmonary valve. The pulmonary valve that you are seeing here, will also prevent the backflow of blood into the right ventricle. That means it will make the blood to keep going straight into the what? Into the pulmonary artery and then into the lungs, so that it could be oxygenated. Now, on this part, you can see the pulmonary vein. The pulmonary vein is coming from the lung. Now the blood that has gone to the lung has been oxygenated. It then comes back through the pulmonary vein into the what? Into the left atrium. Now in the left atrium, between the left atrium and the left ventricle, you have the mitral valve. I told you earlier that the mitral valve is also referred to as a bicuspid valve. Okay, so the purpose of the mitral valve is to prevent the backflow of blood into the left atrium. So the blood from the left atrium move into the left auricle, into the left ventricle, and when the blood gets into the left ventricle, the mitral valve or bicuspid valve will prevent it from flowing back into the left atrium, and then from the left ventricle, the blood will enter into the aorta. Okay, this is the aorta. As you can see here, the blood enters into the aorta, but then don't also forget you also have another valve here. Okay, and that is referred to as the aortic valve. The purpose of that valve is to make sure that the blood keeps moving forward into the aorta and the blood does not return back into the left ventricle. So when the blood gets into the aorta, you can see the aorta, which we have said is the largest artery, divide into several parts. Okay, so we have some of the artery, the head, we have some of the artery going to of the body. Each of those artery have their own separate name. And then before I leave that, you also look at the ventricular septum here. The ventricular septum here is to prevent the blood in the right ventricle from mixing with the blood in the left ventricle. As you know, the blood in the right ventricle is deoxygenated, is poor in oxygen, but the blood in the left ventricle is rich in oxygen. So the ventricular septum will prevent the blood from mixing. Okay, so this short video is just to explain to you what we have said so far, just at a glance, and I hope you appreciate this more and you understand it. Thank you.